Great. Okay, continuing on, we just went over the notes for proving lines are parallel. Just wanted to give you some examples from the IXL lesson, some problems you're going to see. So, this prompt tells you to complete the proof that line TV is parallel with line QS. So let's find line TV is parallel with line QS. Now, yes, they appear parallel, but notice that the arrows on both are different. So at the moment, we don't in fact know that they are parallel. So I'm going to walk through the proof. They've completed most of it for you. It's just the last question, I believe, you've got to fill in. But we'll walk through it. Statement 1 says that QS is parallel with HJ. So just like all of our other proofs, that has been given to you. Okay. Statement 2 says line TV is parallel with line HJ. TV, HJ right here, that is also given to you. It's given to you in the picture by these two little triangle marks. They're like congruency tick marks, except they mean that the lines are parallel. Okay, statement 3 says that angle PRQ is congruent with angle HIP. So let's find angle PRQ, that's this angle, is congruent with HIP, so this right here. Now, we're allowed to say that because those are corresponding angles. They're corresponding across these two parallel lines. We know those two lines are parallel because they both have two triangles saying they are parallel. They're like that pair. Okay. Statement 4, angle HIP is congruent with angle PUT. Here's HIP, and then PUT is right here. Well, that's enough to say they're congruent because of those two lines being parallel. And again, those are also corresponding, just corresponding across two different parallel lines. The next statement down says angle PRQ is congruent with angle PUT. So let's find PRQ, it's this one, is congruent with angle PUT. Well, you may have seen it already. This is the transitive property, and here's your link right here. So we basically jumped from PRQ is congruent down to PUT. That is the transitive property. And now, if we know that angle PRQ is congruent with angle PUT, then we can say that line TV is parallel to line QS by the converse of the corresponding angles postulate. Remember that if we are using these postulates to prove that lines are parallel, we will be using the converse. Okay, and then one more example. It's also sometimes the case that we just want to use this information to prove that different parts, different angles are congruent. So, complete the proof that angle SUV is congruent with WXZ. Okay. Line HJ is parallel to line TV. That has been given to us. That's your first statement. It has been given to you. Let's see. HJ is right here. TV is right here. You know that they're parallel because of these two triangle marks. Okay. We also know that line HJ is parallel to line YW because of these single triangle marks. So it's given to you by the information in the picture. Statement 3, angle SUV is congruent with angle JIS. So JIS, I'll make a mark. JIS is right here. SUV is right here. Here are the two lines. Here's your transversal. So those are corresponding angles. Statement 4, angle JIS, right here, is congruent with angle WXZ. WXZ. And we know that because these two lines are parallel by these two triangle marks. And those two angles are alternate exterior angles. And lastly, You may have seen the link already. Angle SUV must be congruent with angle WXZ. Because of that link right there, the transitive property of congruence. And notice in this example there was no converse of any of the postulates because we weren't attempting to prove that the lines were parallel. We were told that the lines are parallel.